Hello everyone and welcome to our webinar. So my name is Ricky Cartwright and I'm the Head of Technology at Progtex, and I'm going to be administering this webinar, and I'll be joined by Mary Samuel, who's the technical mastermind behind today's webinar. Hi Mary.
Hi everyone, my name is Mary and I'm a digital manufacturing engineer at Progtex. It's lovely having you here, Ricky.
Yeah, thank you, Mary. Yeah, so basically, before we get started into the main webinar content, I just want to let everyone know that there's going to be a question and answer session at the end of the webinar. So if anyone has any questions throughout this, please put them in your comment box in LinkedIn, and then we'll be able to see those, and I'll put some of them to Mary at the end of the session. So lots of challenging questions for us, please. That's what we like. And then we'll get started. Should we go on to the first slide, Mary? I think I'll cover the first few, and then I'll hand over to you for all the interesting technical content you've created for this webinar, right?
Perfect.
Great. Thank you very much. Yeah, so before we really get started into all the technical content that you've come here for, I just want to give you a very brief overview on who we are. So basically, Progtex is based in Northern Europe. And we specialize in construction, infrastructure, aerospace, and automotive manufacturing. And our primary goal really is to work with customers and help them reduce their risks, timescales, costs, and things like that for their on-site construction or off-site manufacturing. And we do that through a combination of novel automated solutions, sustainable fixturing and tooling, or as we're going to focus on today, digital manufacture. Next slide, please, Mary. Yeah, so before I hand over to Mary, I just thought it would be good to give you a quick introduction to the software package we use for our digital manufacturing solutions as well. So this is everything Mary's created and shown today is primarily done with this software package, and that's called 3D Experience. So basically, it was developed by Dassault Systems, and that's the same company that made SolidWorks and CATIA V5, so you might know those pieces of software. And the idea is that rather than being a piece of software, it's a platform, and it's bringing together kind of all data that a business might need. So that could be CAD, Excel information, logistics, automation, all into one single area and one single source of truth. And then the idea is to combine that by also bringing together people from across the business so that they're all able to access the same data at the same time, collaborate, and there's one single source of truth, essentially. And so basically, it's like a catalog of applications that a business can use for design, simulation, analysis, project management, etc., etc. All kinds of things are in there. And yeah, so that's basically just a very quick overview on it. And then if we move on to the next slide, I think we've got one slide here just on the webinar series that we're putting out at the moment. So hopefully some of you saw some of our previous webinar that Sofian gave a few weeks ago, and that was looking at digital simulation for on-site facade installation. If you didn't see that one, it's still up on LinkedIn. I think you can access the replay at any time on there. I think you can probably get it through the Progtex LinkedIn page. But if you can't find it, drop us a message and I can share you the link. And then a few weeks ago at Digital Construction Week, my colleague James gave an in-person talk around worker safety and how digital manufacturing can provide huge benefits for worker safety. That was a really good talk. And again, if you're interested in that topic, we don't have a recording of it, but we've got all the presentation material, we've got some good case studies. So we're happy to share some of that with you guys, or have a meeting to discuss it further if it's of interest. And then, of course, we've got today's webinar, and then we've got 2 more coming up in the future after today. So we'll give you a bit more information about the next webinar at the end of this session of the dates and times around that. And so with that, I think that's probably enough of me talking right now, and Mary's going to crack on with what you've all come here for, right? So.
Yeah, thank you, Ricky, for that. Now that we know what 3DX is, we should probably see how it works through the AEC sector of this webinar. So today, what we're trying to figure out is try to understand these following main questions, starting off with why we need to move or start thinking about why we need a parametric factory design, which can help us in the future. Second is to understand why we need to design for manufacturing, construction, assemblies, how to assess workers' health safety, not just to understand where he interacts with his tools, but also to understand how quickly he can reach his tools too. And lastly, knowing that communication is key on the field, and how does that play with your work instructions. Just gonna hide that. There we go. Anyways, moving on. So there are a lot of customers that come to us, and and they want to move towards a product-driven construction, but they're all right now in a project-driven construction environment, and so what happens is that they start with a 2D. Oh, I should say, what is product-driven construction? So basically, product-driven construction is where a customer starts off with architectural elements or architecture based on 2D and 3D, and then they move on to construction by the customer, or let's say they integrate that architectural design to the very nut and bolt to it, and then all that is done with his past experience, and then that project moves into another person where he then moves layers it with things to put on resources, like understanding what all equipment is required to it, and that's all happens with his past experiences in that specific domain. And that happens over and over again for a multiple of projects until they realize when they come on site, there's so many other risks and factors that come into play which they hadn't thought about in that 3 steps of architecture when it comes to construction for that architecture base, and then understanding all the resources that come to. There's so many other questions that come to when you try to put that implemented on a real life scenario. And what I'm trying to get to is the fact that why we need product-driven construction is because there are a lot of repeated products that come into play when you start doing the things over and over again, knowing that there's a lot of common products and processes involved. And so over here, you can see that always you tend to have objects which are repeated throughout your whole building phase. So you have facades, you have windows, you have doors, you have columns, and you tend to repeat that quite often. And so, so you have all that coming into play, and then you have a construction product development, which is all your processes that come into developing that product. And so all of that comes into play when you try to put that all in your product library. So now you try to imagine that, okay, now that you have all your projects from your previous encounters with all the customers, you all have all your repeated products, you also have all your product development phases that you have with it, and you tend to do all these processes which are also common to it, like you're going to do an on-site installation, so you need to do a DFMA on it. You need to understand, okay, how many resources I need, or I would, if I have a tiny building, I would have a tiny crane, and so things like that. You could have all those installation process library all stored in a place so that there is knowledge transfer. And so you'd have also offsite fabrication if you want to look for like an offsite manufacturing concept. And so all of that moves into play, and then you can end up having a library for all these things. So there is a concrete a workflow before you even start a project. So you're not starting off quite fresh or quite new when you try to do every project as a unique object, but you're trying to create a project with unique process. Does that make sense? You're trying to look at it the other way around. And so now that you have all of it, all your template basically, like of all your products and all your installations and all your prefab stuff, all of that. Sorry.
No, go on. Yeah, if you go back a second, Mary. Yeah. One thing I was just gonna jump in and say, yeah, really good explanation there. And I think one thing that we've seen a lot in this kind of like our view of the state of the construction sector, of working with construction customers, is that actually there's 2 categories of ways people are working, and that's like you described, the project-driven construction, where people are just focusing project by project. They're not really capturing the lessons learned and repeating that unless it happens just by someone happening to be on the same project and have seen those same 2 problems. Yeah. And then obviously there's a drive towards more product-driven construction with things like modular housing and prefab walls and things like that coming in, which are various obvious examples of product-driven construction. But I think there's a lot of examples that are not so obvious to people are things like stairways, lift shafts,
exactly,
columns, things like that, that are actually all repeatable products. MEP ducting's another one that's maybe a little bit more obvious, but it's, you know, basically most buildings, most construction projects, a lot of the elements of it are very repeatable, very repeatable products. And so you see a lot of companies trying to develop these products. And this is kind of the way we think things are going right now, this product-driven construction. And then the next slide that you're about to show is like the way we think things are going to be going in the future, and the way we're, you know, encouraging people to go with it, right? It's taking the next step after that.
Exactly. So how we can use that library structure to then implement it on different multiple opportunities, and try to configure that standard product based on your customer requirements. If you want it really big, really tall, how many floors you want, and you can configure based on that. Now that you have all your product library, and then try to do your site simulation simultaneously to the offsite factory. And so there is a link between both of them. So so you can have you can have an on-site deployment parallel with that, so that there is a feedback loop that plays through it. And so whatever happens in your simulations, you can optimize it. You can always communicate it with people on site, and all that feedback of knowledge is all brought back to your library, so that next year when you try to do a new project, there's no hidden threads or, you know, lost links as to, oh, how did we solve that previous problem? Exactly. So there's always a link to, you know, finding that situation, preventing that situation from happening. But like all things said, I think each project has their own risks and factors to it. So every project looks very different, but I think most of it tend to lean towards a certain direction. And so I think having this knowledge capture can help it, you know, try to not aggravate the situation, if that makes sense.
Exactly. There's like, no matter how much planning or simulation or physical trials you do, you're never going to get it right first time. You're probably not going to get the perfect process or the perfect installation sequence 10th time. But you're going to have, if you're capturing all the lessons, you're going to have gradual improvements until you refine it to the point where it is as good as it can be. And then you're only going to do that, like you say, by doing this configure product, capturing everything and reusing all of that knowledge and learning data.
Exactly. So moving on. So now we know that we're making a simple factory, a configure simple factory. How do we start with that? And so we start with having all our templates from our previous projects. We've got bricks, which are for our repeated products, like our facades, our columns, our flooring, to our rooftops. And we put that all up in our CATIA model and try to put a smart design on it. What I mean by smart design, I mean a parametric design to it. And so I can like change this value. So this is an early mock-up. So you have, you know, structural elements coming in play here. So I've put a skeleton to see, okay, if I want a height of, you know, 4,000 meters, how does the building look? And it doesn't have to fit. This is quite easy to like manipulate it in a way that, okay, let's say our customer is quite unsure as how the design looks like or what his requirements are. We can always change it to, you know, tailor his taste or what he is looking forward to. And so I think this is quite helpful. Before Ricky asks me a question, I know he's gonna ask me a question. So I know his question will be like, oh, what about the architectural elements? So the architectural elements are also linked to your parametrics, and so you can see them all happen. So I've changed the height of the building, and so you can see, oh, the rise of the building changes too, and so you can see your structural elements move along with it, so that your architectural elements which lay over it also change parametrically. And it is easy to, like, you know, visualize, okay, if I'm going to have a building, how many more columns do I need? If I'm going to have a small building, how many more facades am I going to need? And gives me a basic overview as to how things are going to change. But so it's configured because I can change all my elements, and I'm not designing anything from scratch here. I'm using all my elements from the previous projects that I've used, and, you know, put parametrics on it, and then change the length, change the height, so I can like explode it or minimize it and see how it fits my project.
Yeah, absolutely. And this is quite an interesting example, actually, because what you've done here, you know, in that previous slide we were talking about configured product driven construction, and what you're actually almost taking it to the next step beyond that of saying, I'm gonna have a configured building that brings in all my configured products together and automatically configures them based on the overall requirements for, you know, the building, the factory, the hospital, or whatever it is you're doing. So it's having that next level of almost automation of the process and templating and reuse, because you start with your configured products and then you bring that in to the full end solution and have, you know, you set the requirements for the building and that. Yeah, it's really, really great.
Thank you, Ricky. Moving on. So now that we know what our product looks like, what my factory looks like, I need to understand what are going to be my on-site products that comes to play. So I need to know my Lego sets basically as to what are all the elements that come together to make this building. So I know there are going to be columns, there's going to be a slab for my floor, there's going to be facades for my walls, there's going to be rooftops for my roof, and things like that. So you can either base it based around your structural and architectural elements, or I just base it off, you know, columns, facades that you can see on the figure. And now that I know all my Lego sets that are going to come together, I need to know what process it follows. So I know first of all, the floor comes first. And as for my floor to come first, I need a cement truck that comes to the site, deliver cement onto the floor, and then let it sit for a while till it cures. So I need to have a cooling period for it. And then can I only insert all my, you know, or drill holes for my columns onto the floor. So there's a line of thought that comes to play in that. And so you start off with your cement floor, then start off with your columns after that, and yeah, so you can visualize how your process flow is going to go. And all this happens all in 3DX again. You're not moving from any other application or your software here. I'm changing applications here. So I started off with CATIA to design my factory, and now moving on to Delmia, specifically manufacturing item definition to create my manufacturing items, also called as MBOM. And here I have an example of a facade being assigned to my Lego tiles that are created that are coming to my site. So I've linked it all. So my EBOM's linked to my MBOM, and then now I've linked it to my process where, you know, I've put tiles for each of my columns here, and my cement floor, and the columns that come after that. And what's interesting here is that you can tell what comes first, what comes last, and so you can just drag and drop and link each of them. It's quite, you know, fun here. Very easy things. What another fun fact is that, let's say tomorrow your EBOM changes to or your design of your building changes to you know, 16 columns on one side, 14 columns on the other side. It will, since it's all linked together, it will move on to the rest of the process. And so in your process, you will see there are only like 16 columns to be assigned in that process. Or let's say in your MBOM type, you will see only 16 type because it's revised itself, or it's how do I say it? There's a data flow between each of them, and so it's very convenient to see if there are things changing over here. That you also get notified if you do an inconsistent link to it. And so it's not hard and fast rule that if I have a building of, you know, 30 columns, it's going to be 30 columns until I finish it to the end. Is it like that? If, let's say tomorrow things change, and things are bound to change in this in the real world, and so yeah, it makes it very easy and convenient that you're not going to like start from scratch. Although you have your process, you have to like change few nicks and bits of it, but that makes it easier for you to, like, you know, get to revision and things like that. And that's life cycle of the data.
Absolutely. And I'm going to emphasize this a few times in this webinar, so sorry if it gets annoying, but you know, the whole thing of this is a complete thread coming through. Exactly. So everything's linked. So this is all linked back to the configurable EBOM that you saw just now, the factory building that was parametric. So again, Mary can adjust that building, and some of the changes will flow through into here, and you know, everything that's being done here in this planning stage will flow through to the later simulations we see. And that's the huge piece of value out of it. You know, a lot of people we see do this kind of stuff with spreadsheets and this kind of planning, and you know, you can make do with that, but you're losing so much opportunity in terms of the amount of rework, it being locked in one person's head who understands that spreadsheet, and you know, this is a much better way in the long term to
there's knowledge transfer basically.
Yeah.
And if anybody new starts it off, he's not lost as to, you know, oh, I don't know what I'm doing. But yeah. Okay. Now that we know how our Lego sets are going to come to the site and what comes first and what comes last, we can connect them all to understand, okay, you just have to put plus the play button on the top left corner and it plays all the processes that you have created and shows you how busy the site looks. It can tell you, okay, how many columns are going to be delivered. It shows you what the equipment is going to come in there. It can show you, okay, the health and safety risks are going to come involved if you're going to use a crane around there. Like, you will obviously need, humans to have their hard cap and, shoes appropriate for that specific operation. You can analyze, okay, how much time is required for each of these processes, or how long do I need each of these resources to be allocated for that specific operation. And I think this is quite valuable to understand before you try to do logistics. You have an idea, okay, so I'm going to do this operation for installing the columns. How many times, how many days do I need my truck for, or how many days do I need my crane for to get each of those elements? I think it's quite informative in that sense. Yeah, moving on. So here's a comparison of a 4D builder. It's the same thing. I'm just playing my process build that I created with resources and without resources. So when I mean by without resources, I don't see any of my cranes or humans around there. And what I mean by build by fairies, it just comes, like an animation. That's okay. I know my building. I know I've got 16 columns on the west side. I've got 4 columns on the right side, and all that comes together. But this is quite easy to understand as to, I think when our customers are quite unsure as to what comes first or what comes last, or do my rooftop comes first, or do the column facades come first. Things like that kind of plays an important role here. But when you move on to a build up with resources, you understand, okay, I can analyze how much more how many people are required for that specific operation, or is there like a need for a specific crane for that operation because my humans can't reach it, or let's say I need few other drilling equipment for that, for the drilling of my screws into the facades and things like that. Come to ask, you try to ask questions, but I feel apart from that, I think when our customers try to understand, okay, do I need any specific, tool sets? The video with resources helps you understand, okay, I can work around with tools sets. We can always change it, but you have a basic idea as to how your site is going to be looking like.
Yeah, definitely. And how I always like to look at this is it's kind of like the 4D build up on the left, the build by fairies version, is kind of like almost like the architect or the designer's view of the 4D build up.
Yeah.
It's showing the sequence, but it's asking a lot of questions.
Yeah.
And the view on the right is kind of like the constructor's view or the manufacturer's view of like attempting to answer those questions. It shows the sequence, but it doesn't show how any of this is happening, how it can be done, what equipment's needed, how many people are going to be needed, how much room it's going to take to perform that operation. And then I think what's really good about the view on the right is it shows you the plans, tools, and equipment, where they're going to be at any time, how they're going to interact with each other in space. The one thing that's missing, I think, from the view on the right is kind of you have the equipment there, but how do you know that that is the crane you selected is the right piece of equipment for the job, or where you've put it is the right position for it to be able to reach and do what it needs to do? Because obviously things are just snapping in place in this 4D build-up, right?
Exactly, and that's a good question because my next slide talks about how you can have all your resources allocated to it. So Ricky basically went by byte. So here is a basic example of how far do I need my trucks from the site, or do I need people to come and commute to the truck so that they can pick up all the equipment from there. And just like Ricky said, I need to know how far do I need my crane to be. Is it going to clash with anything? Is it going to be obstructed by anything? And so this perfect video shows you, okay, if I'm going to use a crane to pick up my roof support, how far is it going to be? Is it going to be at a clash? Can I position in a specific way where it's going to, still do the job but not obstruct into anything?
Yeah.
I think we had a project where there was a customer who wanted to know is it better to use a smaller crane, or do we specifically need a big crane because they had budget constraints? And when you check it out further, when you can see, okay, you can have a small crane, but if you're looking at the long-term process, like only for this specific operation, yes, you can have a small crane. But if you have a bigger site, or let's say for a taller building, you will definitely need a bigger crane because you need to reach that altitude. And so these are questions you can answer when you do all these simulations. And again, I have only switched from process planning app to assembly evaluations, all in Delmia. So there's still that thread flow of I just selected that specific operation of inserting the or installing the roof column, and it lets me do a simulation on it with the resources that are assigned to it. I can always change the resources based on what the customer requires. If you want a smaller crane, like I said before. But yeah, this lets you understand, how far and how close I need my resource to be.
And this kind of stuff really is invaluable for answering those kind of questions. I'm sure a lot of you guys, if you're involved in these kind of discussions, you've had those questions of, is it better to have like one bigger crane that can do every job we need it to do, but then that crane is going to be the bottleneck, right?
Exactly.
Or if we have a few smaller cranes, what are the limitations on them? What can't they achieve? And how is the demand on those resources going to be handled? And between that 4D build-up planning, where you can see where all the resources are at any one time and how they're going to be allocated, and the detailed assembly simulations for the tricky areas where you can see what's actually achievable and feasible and possible with the tools you're selecting, you can answer all of those questions through a data-driven way, right?
Exactly.
Yeah.
Moving on, now that we know how we've assigned or positioned all our cranes and resources in each of our operations, we are yet to assign the position for our workers. And it's quite important to know how our posture is when we are working in a very, let's say, very, I was going to say toxic, but very a high demand area, basically. Here's a nice video of me trying to figure out, if I have a human placed in a telecommuter, how is he going to be? So is he going to be far away from the drilling bit, because he needs to drill holes into each of the specified areas on the roofs? And I position his hand and I see, okay, he's quite far away, upright. But then when I bend him down from his spine and pelvis, he can then reach. But when I zoom out, you can see, okay, he doesn't look that comfortable in that position, does he? And so I'm going to do an analysis to actually prove that he probably isn't. And then it looks like he got a score of 7, which is pretty bad, because he strained his forearm, he strained his wrist, he strained his posture, and it's quite easy to see things. So now I know, okay, I need to either move my telecommuter a bit lower so that you can actually reach, or probably make him bend or kneel on the telecommuter so you can actually not strain his back but still do that operation for, let's say, the next 1 hour, when he still has to drill holes into the rest of the roof. And this is an easy way to see with the root analysis how, if he's going to be strained or not strained.
Exactly, and I think this is obviously a fairly simplistic demonstration of it, just to emphasize the points of how it works and what you can do. Obviously the solution to this is quite easy to adjust the height there of the cherry picker for him. But we've used this multiple times on real projects for like huge stadiums that are being built, and the facades being installed, hundreds of meters in the air. People need to work at that height to install it, and they need to. It's not easy to get the basket where it needs to be. So people, the plan is for people to reach out quite far with a dedicated tool, and then do up another bolt. And actually, how do you know for sure that what you're asking someone to do is going to be safe for them, and they're going to be able to do it with the tools you've got for them in those kind of scenarios, and the tools you've got are going to be fit for purpose. And these kind of simulations are a really great way to prove that out, and assess it and check off all your safety analysis are really early in the process before you spend money on tools and equipment, right?
Yeah, quite important to see that you're not wasting money on okay, I know this person's going to do, I know my crew can do any job, but then, you have, before you start the project, okay, you see can the crew actually fit there?
And the last thing you want is for them to feel that they need to just cut corners to get it done.
Exactly.
Because you haven't set them up with the right stuff. So they're leaning out, undoing their straps to lean out further just to get it done, to get the project on time. And, things like that happen. And this is a great way to make sure it doesn't need to happen.
Yeah. Coming to work instructions, we all know that communication is key. It's how we communicate the process is important, because we need to make sure that what we have planned happens to be as built. And like you would typically do when we prepare a paper work instructions, you can provide text instructions and graphics. And in Davia, you can create your work instructions which are related to your specific operation, and you can add your text instructions with it. You can have your alerts assigned to it. You can assign your 3D views to it. So you're not limited to having a 2D figure, but you have a 3D view. But 3D experience does not just stop you there. You can also see it on a dashboard. And so let's say you want to take it on site, you can always have it on your iPad or on your phone, and you can still check out all your work instructions and have a 3D view on it. So you're not just limited to your 2D view. So here's a simple work instruction that I created on a specific operation where I think this is an operation for installing the facade. And this is the first facade that I'm installing here, and I can name each of my objects or products that are coming into play here. I can add an alert to it. I can add a text instruction. It's quite easy. You can name it based on what it is, and then you can export it in the HTML format, and it lets you open up these hyperlinks, which then links you to a specific facade. And then when I click on that again, I can see all the views that I've created. I can see all the text instructions that I've assigned to it. I can see all the timescales that are involved in it, and it's quite easy to change it. Let's say tomorrow I use a bigger facade, or the facade design changes to a bigger panel. It will show me a bigger panel, but I just have to change the position of it, or probably just change the color of it, because I'm usually my work instruction to be yellow, but now it's orange, and I just have to change the color to it. But apart from that, I'm not creating a new view again, or I'm not assigning it again. And there's always that that thread of knowledge or the thread of data that is linked to it. And so I'm not fumbling about it. Oh my god, I need to spend more time trying to change it all over again because somebody in the design team changed it. And so yeah.
Exactly. We see a lot of people creating these kind of work instructions just in PowerPoint or whatnot, taking screenshots from the CAD, pasting it in there, and then there's nothing driving those work instructions to be updated if the design changes or if the production process changes. Whereas here, it's automatic because it's linked together. You change the design, you change the production process, you reissue, and then it drives you, notifies you that you need to update the work instructions and reissue them as well. And that kind of collaborative sync up, means that people always have the right work instructions at the right time for the right product they're working on.
Exactly. It's always in the right revision too, so you can always improvise it, so that you can always be working on the right revision. And yeah, that's a nice iPad which I put there. We can always see it, view it all there. So perfect example of you can have somebody working on the work instructions offsite and have somebody on site also looking at it simultaneously. So there is always
anything with a web browser, right?
Exactly.
If you want to do it on your smartwatch, you probably could. I wouldn't recommend it, but you probably can.
Actually, we should try that.
Yeah, we should.
Anyways, just to summarize everything that I've brought you to today, so I walked you through the fact that you can start off with templates and bricks to create your factory model, and that doesn't stop there. You can also have it configured to that specific requirement as to based on your height, the height of the roof, the number of columns, etc. And now that you have a configured product, you can move on to creating your Lego sets, which I showed you in your MBOM, where I just switched apps from Katia to Delmia and basically created all my Lego blocks, Lego sets that come together for your developer, and then moved on to show a process build where it starts off to say, okay, I'm going to have a tile for my cement to come in, and so I need my resources to be assigned to it, and okay, what all steps are required so that my truck can come into the site and leave the site, and then there is space for all the other resources to come in play. So that's process engineering, and then I move on to resource allocation, resource layout, on-site and off-site, where I show you can assign all the resources and see, okay, how far or how close I need it to be. And then moved on to show you what is work instructions and how does work instructions play with your process engineering that you created for your process build, and how that all includes all your manufacturing simulations to assess all your risk and let's say all your risk and DFMAs are coming to play when you create a factory. But yeah, this is quite helpful to understand that all this happens all in one software. You're not shifting from one software to another software. It's always between either CATIA and Delmia and then Novia, where you're trying to, well, Novia is more for life cycle and you're trying to revision it. But CATIA and Delmia are the most used apps that we use to show all these possible scenarios that you can play with.
Absolutely.
Yeah.
One thing I was just going to jump in here and mention, thank you very much for that technical content, Mary. That was absolutely fantastic. So we're running a little bit over time, so apologies for that. If anyone's got to rush off, this will be available on replay and you can catch it. So I'll run through these next few slides very quickly, and then we'll get to the Q&A session. But if anyone's got any questions, again, chuck them in the comment box and we'll answer as many as we can. So yeah, brilliant. Thank you very much, Mary. So I just wanted to mention that we've got another webinar coming up on the 11th of July. So this is looking at a bathroom pod solution being installed in a hospital or hotel or whatnot, where it's very repeatable through hundreds of rooms all having these bathroom pods installed in them. And this is diving a lot more into that kind of production simulation aspect of the actual details of the build up and two different scenarios, prefab installation or stick built on site, and then the details of those different installations and understanding what's going to be better for creating one of those or installing one of those products, and then what's going to be better in terms of the sequencing for the many throughout all of the rooms. Is it better to have one crew working through, if you have 2 crews or 3 crews working in sequence? It might be more cost effective, but are they going to get on top of each other? Actually, is it more cost effective to have 3 than 2? Those kind of questions we're going to be looking at and showing how these kind of simulations can answer. So hopefully that'll be of value for everyone. And then, yeah, just a quick one to say, if you like what you saw here, the kind of simulations, and you want to get hands-on with it straight away, we get people asking us, how can I try some of this stuff out? There's a 3-month trial available for £500 per user to do it. You'll be able to do everything that we've done here, and obviously we can support you in that if that's what you want to start doing to evaluate it for your business and see what it can do. We can help you get set up with that and everything like that as well. And then we also deliver training as well as the licenses and technical support and consultancy to go alongside that. However much or little help you need, part of our job is to help other people know how to use the software and get them up to speed with it. So great. No, that's fantastic. So yeah, there's a few of our contact details on the slide there. So if anyone wants to get in touch, please reach out with us. We love chatting about this kind of stuff. And I think that just leaves us for a couple of questions. So I've actually got a couple here, Mary, that I've prepped for you, I'm sorry to say. A couple of my questions. So I'm gonna prep a few of those to you, and then if any other questions come in, we can answer those. Okay. So one question for me is, obviously a lot of construction customers, they use other software for design. They use Revit or AutoCAD or SolidWorks or whatnot. So how would that work if they don't want to change all of their design teams and design processes to CATIA? Does that mean that they can't do any of this stuff? Or
no, absolutely not. So 3x is very convenient that way, where you can import all your different data types into it. You're not restricted to just use CATIA. You can use SolidWorks, you can use Revit, like you said. You can import so many other different types of files into 3x, and then yeah, I'm guessing you're having a configured product at that point, and so you can always continue from there to create your manufacturing bill of materials and then your process and yada 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 after you show. But yeah, you're not restricted just to start with CATIA. You can always start with any other software, and you can always import it back into 3ds and continue the build from there.
Fantastic. I've got 2 more questions for you here from me. So sorry about this. The next one is, so say we're running on through the process that you just showed in the business, and someone from the design team goes in and makes a load of changes to the design of the product, and I'm working on, you know, the process plan and getting that right. How do we make sure, how can we ensure there's no disconnect between the design being changed and my process plan, and how do I know if anything has changed?
Oh, that's a good question. Okay, so I'm currently working on a project where, you know, there are things moving and changing in the design phase, and I'm like actually in the process stage, and I'm just like, okay, I need to know what's happening, and so either you update it, and you see links that are created between your MBOM and your process with your engineering bill of material that you created. And if there's something changed in your EBOM or in your design, you will see it link in your MBOM, which shows a partial link. It's not a full circle, but a half circle. And so that's when you realize you can click on it and then go to this icon called inconsistent link. And it shows you, okay, there's an action that needs to be done because there's a product which has, you know, been revised or is updated or it's changed this product or it's been replaced by another revision. And so it gives you a prompt before you save it, saying that, okay, there's something being changed, you want to look at it. And so the 3x tells you, you know, it's very interactive in that way that, you know, there's something changed in your design. It always tells you that, you know, you are working on the wrong revision. You might need to, would you like to change to it? Would you like to work on a new revision? Or do you want to replace it? Or do you want to upgrade it to a different whole new product? And yeah, it gives you that, you know, life cycle change where, you know, there's always that thread of data that's going to be there. But yeah, does that answer your question?
Yeah, perfect. And the final question from me, and I think we'll wrap this up and let everyone get going, is a really common one that we get asked a lot is, how much time does it take to create these kind of simulations? Because I think a lot of people are concerned that, you know, the stuff we show on the screen here is very like high quality. It looks like a lot of time and effort goes into crafting them, and then is that going to add loads of work to their planning teams to spend all their time creating all these simulations that means there's actually not going to be that much value, right?
No. Well, you don't have to do simulations for each and every column. I mean, you can just do for one column and it's going to be the same for the rest of them, only because the position of the crane is going to change every few meters. But if you know the basic idea of how your crane is going to pick up that column from the track or from the truck to the floor, I think that simulation is pretty much enough to understand what's happening in that scenario. But to do the scenario, it doesn't take that long. To be fair, you're just moving out things. You're trying to, you know, extend the column, not extend the column. Try to understand, okay, how far does it need to be? So it's more positioning it. So it doesn't take a lot more time than, you know, actually doing the process, or, you know, compared to, you know, trying to understand, do I need all these building blocks to, you know, create that building? And yeah, it's quite easy to do if you're not trying to like make it really heavy, you know.
Absolutely, yeah. Absolutely. Like, we're all about making our life as easy as possible here, and that's why, you know, I think initially it'll probably take more time because you've got to get your processes set up, you've got to get your your models for your resources and your cranes and everything set up in the right way. But once you've got all of that set up, really it's just a case of bringing in your items and using those. And the other thing, I think I really like what you said about not having to simulate everything.
Exactly.
Because what we tend to recommend to people is that most of the stuff that you're doing, you know how to do, you've been doing it for years, you're not going to need to simulate it to prove it out. But it's that tricky 15% of things where it's a new product, a new scenario, a new environment, or a new tool or something like that, that actually, that's where you really benefit from that simulation. So.
Well, yeah, simulation makes your life easier to understand how the risks are going to be.
Yeah.
Well, yeah.
Great. All right. Well, I think that's it for today, for the time for everyone. So thank you very much to everyone for joining us. And thank you again to you, Mary, for putting all this together.
Thank you, Ricky, for hosting all this.
Great. And I hope everyone has a great rest of your day.
Bye.
Thank you. Bye.